Professor. This is Dylan Kelly, and I'll be reviewing experiment 4, which is percent water in a hydrated salt. The objective of today was to use gravimetric analysis and to find the percent water in a hydrated salt. The reason why is because there were 4 different chemicals that were used in this unknown solution that I'll be talking about in a second, and that's calcium sulfate 2 hydrate, magnesium sulfate heptahydrate, sodium carbonate hydrate, and zinc sulfate heptahydrate. So the procedure starts with you preparing a crucible, a ring stand, and a small iron ring. It is very important to heat up the crucible because you want to leave out the volatile impurities that may be in there from a prior experiment. The reason why these are detrimental to the experiment is, let's say, you evaporate the hydrate in the solution. Well, if there was already hydrate or liquid left over in the crucible, it would add on to your total, messing up the results. After you heat up the crucible, you make sure it's normal weight, you weigh it on a scale, and then you add the hydrate. The hydrate should be about 2 grams. It should be if you don't mess up. After you do that, you put it right back onto the ring stand under a Bunsen burner, but make sure to use the little tongs so you don't get burnt. And you prepare to heat it for 5 to 7 minutes. After doing that, you have to find the mass of what's left, and you subtract that from the total to find the amount of water that was lost. Then you use the formula that we learned in this experiment to find the percent water by hydrate. So that formula is the mass of the water over the mass of the solution multiplied by 100. So for this example, in the pre-lab, let's see here. As you can see, it says, what is the percent of mass of water in copper 2 sulfate pentahydrate? So you take everything from copper sulfate, you add it all up, that would be 250 milligrams, and then for water, it's normally, the rule of thumb is 18 grams for each molecule, so you multiply that by 5 and you get 90. You can also set it up this way, where it's 90 grams of pentahydrate over the copper sulfate pentahydrate, and that would get you 36%. So later on in the experiment, after we are done and we get the mass of water lost, you have to, let's see here, figure it out once again. So for the percent water lost, you take the mass of the water lost, which was 0.38 grams, and you divide that by the mass of the hydrate, which previously thought was to be 2 grams, but in this experiment, I guess 0.02 was lost, leaving it 1.98. After you divide that, you get 0.192, which would be 19.2%. The next step would be to revert back to the table of chemicals that you have and compare the average. And since there was only one trial, there's only one average, and that average is 19.2%. So for this experiment, that 19.2% links up just about the same as calcium sulfate dihydrate, also known as gypsum, which was actually in the procedure of the experiment as being a special type of hydrated salt. So as you can see, let me find it real quick. Yeah, there we go. So calcium sulfate had a percent water of 20.93%, and as compared to the other chemicals, we can see that this unknown solution was clearly best bet calcium sulfate. So after we go on from the lab reports into the post labs, they ask for 3 errors, and that could have happened. One of them was not firing the crucible. It would throw off the weight of the water since something could be left over. Not heating the crucible long enough, results will be thrown off, as the hydrate could have not lost as much as it should have, contributing to results. And then measuring the crucible with the lid on prior, then remeasuring with the lid off. So that would also add extra weight and, skew the balance of the equation. The experiment was a pretty interesting experiment because I feel as if that equation we learned, finding the percent water by hydrate salt, is very important and will be used frequently as I progress on to further chemistry courses. That should be it. Thank you and have a great night or day.